The eighth question that we have is a very conceptual problem which appeared in IIT JEE 2005. This question, if you have the very basic concepts clear, you can solve it in 2 minutes. Otherwise, you will take time to solve this question. We have been given a reaction. The time, there is a data given to us. At time 0 minutes, the partial pressure of X in millimeters of Hg was 800. At t is equal to 100 minutes, it was 400. At 200 minutes, it was 200. We need to find out the order of the reaction. So for finding out the order of the reaction, you can use Kt is equal to ln C naught upon Ct. Let us check if it is a first order reaction. If it is a first order reaction, it should follow this. Therefore, let us write this for this to this and this to this transition. Therefore, K into 100 is equal to ln of 800 upon 400. Similarly, for this to this transition, it should be K into 100 again. This is equal to ln of, this is K1, this is K2, ln of C naught upon Ct, that is 400 upon 200. So we are seeing that the value of K1 and K2 is coming out to be the same. Therefore, it is definitely a first order reaction. So the answer for the first part is 1. Now, instead of doing all this, you could have directly seen the answer if you see the data very carefully. The data which has been given is very typical and it is definitely given so that you see the data and write the answer directly. You need not solve it. The questions in IIT are therefore very conceptual. We can see that in 100 minutes, the partial pressure reduces to half. Now, therefore 100 minutes is the T half supposedly, because in T half, that is 100 minutes, the concentration is reducing from 800 to 400. Now again we see that in another 100 minutes, the concentration is again becoming half, or rather the pressure. It is all the same in terms of moles and pressure, because moles is directly proportional to the pressure. Therefore, in 100 minutes, the pressure reduces from 800 to 400, and in another 100 minutes, the pressure reduces from 400 to 200. That is again halved. Here also it is halved. Now, we see that this is equal to the T half, that is the time in which the concentration reduces to half. This is again T half, that is the time taken for the concentration to reduce to its half value. Now we see that the T half is independent of the initial concentration. Even when the concentration was 800, it reduced to half its value in 100 minutes, and even when the concentration was 400 minutes, it reduced to half its value in 100 minutes. Therefore, T half is independent for concentration, as we find out here. Now this happens only in the case of first order reaction, that the T half is independent of the initial concentration. Therefore, we can definitely say that the order of the reaction is 1. So we can directly say just by looking at the data that the order of the reaction is 1. Now we need to find out the rate constant. Now we know that for a first order reaction, T half is equal to ln 2 upon K. Therefore, K is equal to ln 2 upon T half, that is equal to 100 minutes in this case. So we get the value of K to be equal to 6.93 into 10 raised to the minus 3 minute inverse. So this is our answer for the part B. Now we need to find out the time taken for 75% completion of the reaction. Now you can again use formula to solve the question in a lengthy manner, but you can do it directly, because we know that 75% completion means T is 0.75 and this is equal to 2 times T of 0.5 for a first order reaction, that is equal to 2 times T half. Therefore, this is equal to 200 minutes. This is because we know that if the initial concentration is C naught, it will reduce to C naught by 2 in T half time, and for this to reduce to its half value, that is C naught by 4, it will again take time T half. Now from this to this, it has taken time 2 times T half, that is equal to T of 0.75, that is T 3 by 4. That is the time taken for 75% completion of the reaction. So we directly get the value for time taken for 75% completion to be equal to 200 minutes. Now for the fourth part, we need to find out the total pressure when Px is equal to that is the pressure of X is equal to 700 millimeters of Hg. For this, let us write the reaction down. Over here, 2x gas gives us 3y gas plus 2z gas. Now it is always better to write the equation in terms of pressure. Let the initial pressure was P at T is equal to 0. Now at T is equal to T, this pressure let it reduce by 2P dash. I have taken this 2P dash because it will be convenient to write the others since the coefficient of this is 2. Therefore 2 moles of X when decomposed, it will give 3 moles of Y. Therefore the pressure here will be 3P dash and here it will be 2P dash again. So now we know that P minus 2P dash is equal to 700. We already knew that P was initially 800. Therefore P dash is equal to 50 millimeters of Hg. Now the total pressure as we see is P minus 2P dash plus 3P dash plus 2P dash, that is equal to P plus 3P dash. This is equal to 800 plus 3 times 50, that is equal to 950 millimeters of Hg. So final answer for the total pressure when Px is equal to 700 millimeters of Hg comes out to be equal to 950 millimeters of Hg, and thus we get the answer for all the parts just by simply looking and analyzing the data.